So I was given the problem, consider the production of pure oxygen gas by the decomposition of mercuric oxide shown below. If 15.0 grams of HGO reacts, what volume of oxygen gas will be produced at 28 degrees Celsius and 1.25 atmospheres? And we were given the equation 2HGO solid yields 2Hg liquid plus O2 gas. And so we were told to find liters, a volume of O2 is our end goal. So we have the information 15.0 grams of HGO. To somehow use that to get there. So the first step that we have to do is to find moles of O2. So we know that obviously 15.0 grams HGO. We need to find the molar mass of HGO. So Hg has molar mass of 200.59. Oh, that's not 9. 59. And there's only one molecule, and there's no subscript here. And then O has a molar mass of 16, and again there's only one, so times 1. You add those together to get the combined molar mass of 216.59 grams per mole. Now you need to convert this to, you have to convert 15.0 grams of HGO times. Now we have grams up top, so we have to put grams HGO on the bottom, so that tells us 1 mole over 216.59, and so these cancel out, and you are left with 0.0693 moles of HGO. Now we can use that to find out how many moles we have of O2. Because if you go back to the original equation, you find that we have 2, actually let me do this, we have 2 HGO to every 1 O2. So use that ratio, and so I'll write use ratio to find moles O2. So we take 0.0693 HGO times, now we have to have HGO to O2 so that these cancel out, and so there's 2 to every 1, which gives us an answer of 0.0346 moles of O2. Now for our next step, we have to use this information given here to find out how many liters we have of O2, because we originally asked for volume. So we can use the equation PV equals nRT. Some people like to rearrange the equation before they do it. I find that confusing, so I just take my values and list them and then put them into the equation. So for pressure, we were given 1.25 atmospheres. For volume, that's the value that we're trying to find. N equals the number of moles we have of our thing, so that's this. So we have 0.0346 moles. And then R is our gas constant, so that's 0.08206. The units for that are liter atmospheres per mole times Kelvin. And our temperature that we were given is 28 degrees Celsius. Now we can't use this because it isn't Celsius, we need Kelvin. So all you have to do is add 273, and that gives us a value of 301 Kelvin. Putting this into our equation, we have, let me just move that over there. We have 1.25 times V, we don't have that value, equals 0.0346 moles times, you know what, actually I'm going to make sure, I'm going to do this smaller. 1.25 atmospheres times V equals 0.0346 moles times 0.08206 liter atmosphere mole Kelvin times 301 K. And then by doing so, we realize that moles cancels out, Kelvin cancels out right off the bat. So we multiply these together and we get 0.00284, and then that's left with liter times atmosphere times 301. Leave the Kelvin there. And again, this cancels out. The next equals V times 1.25 ATM. And then these together gives us 0.855 liter atmosphere equals V 1.25 atmospheres. And now divide by 1.25 TM. These cancel out. 1.25 ATM. These cancel out. And you are left with volume equals 0.684 liters, or 684 milliliters, but we can just leave it as liters. This isn't incredibly small. And going back and checking with our sig figs, we were given 1, 2, 3 in 15.0 grams, so we can leave it with 1, 2, 3 here, and this is our final answer.